Hello everyone and welcome to a new episode of Golang Cafe, and today we are going to talk about dependency injection in Go. Dependency injection is a concept that it's going to be useful for you when you work, specifically when you work with unit testing and when you work in projects where you have a lot of components and specifically where you have a lot of external dependencies or external systems that you want to isolate from within your code. Dependency injection, it is not a new concept and it's not something that is coming from Go itself. It is something that's been known in software engineering for a while, and it's something we're going to go through today and see how we can apply to Go and how we can use it to write better programs. So the first thing we're going to go through today is an example we have written in advance. And this is basically a tool that allows us to store data in a file. It is a key value store. It is a database that we can operate from within the command line. It's just 100 lines of code. And I already compiled it. I can compile it again just to show you how it works. So this everything in the main.go file, and it's a key value store where we can set and get values in memory, and those are all stored in the file system, so it's persistent after each run. The first thing we can try is set the value, set Bob to 10, and then we can try to get the value back. As you can see, we can update the value to what we want, and then we can retrieve the value again. As you see, the value gets updated. It is also something that we can use with strings, total strings, if you want to, and you will see that you can retrieve the values as well. So it's very basic, and the way it works is it's an append only file. So you will see here that you always get the last value, even if you had previous values with the same key. So we can just quickly check the database, how it looks like. The database just stores all the values in an append only mode for simplicity, and it will return the last value that it finds with that key specifically. So this code is being written in a way that can be refactored to using dependency injection. It doesn't use dependency injection properly, and so we're gonna go through it and see how we can improve it. We're gonna skip the first part for now, which is just some generic definition of dependency injection. The first thing we're gonna notice is the main function, which is where our engine, if you want to call it, our runner is instantiated and is being run. We have split the program into three different parts. We have the main function, which creates the runner and runs the runner and checks the error. We have the runner, which takes care of parsing the arguments. As you remember before, we set the arguments to store and retrieve data from the database. So the arguments are coming from the command line. We parse the arguments, and then we decide whether we have to set or get data from the database. And then we have finally the database here, which is a database that stores values inside a text file. As you can see, we have a text file in here, text path, and then we open the file each time we set the data, and we get the data from the file. And that's it. So we have just a few, over a few hundred lines of code. If you don't consider all the comments up there, it's much less than 100 lines of code. So it's just composed of three components. Again, the database, file database. So we have the runner, which orchestrates the various commands and send the commands to the database, and then we have the main function, which instantiates the runner and runs the program itself. So we're gonna use now dependency injection to refactor this code, and the objective is to then write a small unit test. At least we're gonna try to write a partial unit test. We are not going to be able to write 100% test coverage. Just be mindful of time. But we are going to go through a use case where we want to refactor this program, we want to write a unit test, and we want to make sure that it is using dependency injection properly. So one of the challenges that you first see when you look at this code is that It has a file name in the file database method here in the constructor, and this is something that is going to be challenging for us if we want to test this code. And the reason why is because if we were to have multiple tests running at the same time, or multiple tests running, you have conflicting file name here. So this could be also something that we will need to figure out and improve in a way. And we may not want to use files when testing, for example. If you can avoid using file systems when writing unit tests, is much better to use in-memory data than to use file system, because file systems you need to have the appropriate permissions to write to the file system. You need to prepare the file system. You need to make sure that the files are cleaned up afterwards. So there is a lot of more overhead, if you want, when you write unit tests that deals with file system. And so we're gonna see now why it is useful for us to abstract all this logic away in a way that's easy for us to test this program. And I guess now we can just jump into the definition of dependency injection. I guess some of you already know what dependency injection is about if you've used in other languages. It refers a lot to objects. In Go you don't have objects generally, you have just structs, and you can have methods associated with those structs, or struct types as we like to call them. So you can think of those objects as referring to Golang structs in a way. The dependency injection has 4 different roles, distinct roles, and you can you can exercise, and you can go down the line of going down some code and trying to understand which part of the code is a client, is a service, and is an interface or an injector. So this is what we're going to go through now. We're going to just go see the roles of the dependency injection and trying to associate each of our parts of the program to each specific role, so that you can then apply dependency injection. To bear in mind the dependency injection taxonomy, here you have different roles, and when you're not using dependency injection, you may not have all of those in place, because obviously not all of those are being used if you're not using dependency injection, but when you are, you will have all of those in place. I would like to start with the service, with the client object. The client object is kind of our subject, is our protagonist in the story. It's the object that it is depending upon a certain number of services or dependencies, as I like to call them. That's why it's coming dependency injection. And just after the client, you have the services or the dependencies, which are the final objects that you are going to be using for your client. And dependency injection tells us that you can, instead of the client being aware of which dependencies it uses, you can select from the outside which dependencies you're going to be setting into the client. So the client isn't aware how to create the dependencies, how to create those services, but it just takes them from the outside when it gets instantiated. The interfaces are something that allows the client and the service to work together. And it's something that is specified into the language. In Go you have interfaces that allows you to specify behavior, allows you to specify methods. So the client itself uses interfaces to define the behavior that is expecting from its dependencies, basically. So those 3 go well together. The client needs services to work, and the client defines the behavior of those services using interfaces. And the interfaces, it's something that the service will have to implement when passed into the client. So those go together, strictly together. And finally you have the injector, which is a more higher level. The injector is responsible for constructing all the things together. It's responsible for constructing the services, for constructing the client, and it then bounds them all together, injects the services into the client. That is then going to be used by the injector itself. So those are the 4 roles. If you're a little bit confused, there is an analogy coming from the Wikipedia article, and the analogy is very simple. It is comparing these 4 roles to for different things in reality. So you have a service which is like a car engine. The car engine can be an electric, can go with gas or hybrid or with diesel. So you have different types of car engines, and then you have a client which is a driver. The driver doesn't know how an engine works, doesn't care what type of engine the car is. It just knows that it knows how to drive the car. It doesn't know that the car has a specific engine. And effectively, the engine is a dependency of the driver. The driver needs an engine, needs it needs that kind of component to in order to drive. Otherwise, he can't use the car. The car cannot work without the engine. And that's the relationship, dependency to the client. So service and client. And then there is the interface, something that connects the client with the service. So the only thing that the driver knows about the car or the engine is how to drive the car. It's just the only structure that he knows when he has to switch it on, when he has to go ahead, go behind, go back, or go right or left. So it just knows a basic set of methods, and those represent the interface for the driver to drive the car. Whether or not the car is electric, gas, hybrid, or diesel, it doesn't really matter. It doesn't really care, the client. It just knows how to drive it. The injector, you can think of it as a parent who bought the car. He chosen the car for the kid, and they gave the car to the kid, but the kid doesn't know what kind of car, doesn't care what kind of car, he just knows how to drive it. So there's a very simple analogy you can apply to that. Now we're going to go through our example, and we're going to try to classify our components and map them to the 4 roles we have seen. The first thing we're going to go through is the client again. It's our main subject, in this case it's the runner. Is the runner because it has is the client because it has dependencies to which it depends upon, and the dependencies, one of them, the main one, is the file database. You would say, okay, which dependencies do I have here? Which external parts, which parts are an implementation detail? The file database and implementation detail. The file database is an external part from which I rely on, and so the runner for us is the client. Runner is the client. Bear in mind that the client or the runner is all of it, so it's all of that, because in Go you don't have the classes like in Java or Python. You have the struct type, and then you have methods associated with that struct type. So for us, the runner or client in our case, it's all this code here. So it's all the runner, the run code, and the runner constructor as well. The dependencies, you guessed it, the dependencies is the file database or the service, how we like to define it. So the file database itself is our service, is the service, or dependencies, how you like to call it. So we already identified 2 of the 4 actors on our side. And we said when you don't use a dependency injection, you may not have all the actors in your code, and that's why you're not using dependency injection yet. And here we have an example of that. Still, we don't have an interface that allows us to communicate between the client and the service, that is more abstract than the service itself. And still, we don't have a clear injector. We don't have someone is going to create the dependency and is going to inject the dependency into our client. So the first thing that we're going to define and try to define is the injector. In our case, the injector is going to be the main. So the main is the injector in our case. At least it's going to be the injector, because right now it's not the injector yet. There is no injection of any dependencies at the moment. But this is what is going to be the injector here, because the new runner is going to be initialized by the main, but we want to abstract those dependencies out. We want to remove the dependencies and pass them into the constructor. So this here, it's the constructor of the function, the new runner. So what we can do, we can just, instead of creating a new file database in here, we can pass it from the outside. And so now we can just pass it from the constructor here. New runner is a constructor and returns a new runner. It takes a database from the outside this time. It doesn't create the database itself. It doesn't know, it doesn't care how to create the database. It just gets it and it used it. So now the new runner is going to have a database, new file database. Now the main is an injector. Now the main is an injector. We still miss one of the parts because we said we have a client, and the runner is a client which needs some dependencies. The dependencies or services are, it's in this case the database. We injected now the database into the client using an injector. Now the last thing we need to do, we need to define an interface. The interface allows us to know how the dependencies are being used by the runner. And so what we need to do now, we just need to see, okay, the runner is our client, the client needs interface, the client needs dependencies, the dependencies are defined, is this one, it's just database. So we need to see, okay, how is the database being used by the runner? And once we know that, we know the behavior of that, and we know then the interface that we want to create, the interface that the runner is using. So we search for r.database, which is the usage of the runner, the database from the runner, from the client. We see that there is just two usages, and the database has a set and a get method. Set receives two strings and returns an error, and get receives a string and returns a string and an error. So now the thing is that we need to create an interface. And why do we need to create an interface? Because we want to create an abstraction, we want to create a layer of abstraction that allows us to abstract away the details, the implementation details of the file, of the database here. So we know that it's a file database, but we don't really want to know the details. It's like saying the driver is driving a car that is an electric car. We don't really care that it's an electric car. And the reason why we don't care is because it's always better to have a more abstract thing in our program, because it allows us to have more interchangeable components. So the first thing we're going to do, we're going to define an interface that respects the usages that we have just found, and then we're going to call it something generic that it respects and reflects the usage of what we are trying to define. In this case, it's just a storage interface. And it has a set method which takes two strings and returns an error, and then a get method that takes a string and returns a string and an error. Our storage interface is going to be used now in the client instead of the actual implementation of our database. And you will know that now everything still works because we have the interface, and the file database implements the interface. The file database uses the same interface as storage, as the one that we have defined. So everything should still work. And now we have all the components that we need for dependency injection. So storage is the interface which is going to connect the client and the service. And it is something abstract. Again, it is something abstract that you have in order to remove the implementation details. The objective is to remove the implementation details from your code, such that the code becomes much more configurable and much more easy to work with. So now we have our file database. We know that the file database implements the storage interface, as we've seen, set and the get method. And we know that we have removed the dependencies from our client, so we have taken out the dependency. We're using now proper dependency injection here, and here we have the injector that injects the dependencies, creates the dependencies, creates the service, injects the dependencies into the service, and uses the service. Now we can just try and build again our program, and we can try and run it again, and it still works as we expected. Now we just want to make sure that this process that we have just done, the process of identifying the dependencies that can be abstracted away and dependencies that can be taken out of certain parts of our program, we can apply this process to not just our client, but we can apply it to also other parts of our program. So here, for example, if we look at that, there is another dependency, file, which is a path, is a dependency, and we are creating that file inside the object here. So what we want to do, we want to abstract these dependencies away, we want to inject this dependency, and this is the whole essence of dependency injection. So now instead of creating the file here, the file name here, we can just pass a path, and this is going to be passed by the injector again. So the injector is responsible again for creating the dependency and passing it into the client. database.go.txt. Let's see if we still have other dependencies that we can take care of. So here we say we have the database dependency and we have abstracted away. And bear in mind that we have not defined an interface for this one. This is just a string, so there isn't really any complicated or any abstraction that we can create on top of that. It's already very abstract. It's a string. There is not much we can do about that. If it was an object, then we would analyze the different the different usages of these objects inside our new file database implementation and see how we could abstract that. But this is already a string, so we don't need an interface. We know that how to work with basic types. Now we have another thing that's are coded inside our runner. It is the os.args. The os.args is something that's coming directly from the standard library, and also the command line arguments start with the program name. So it's something that is populated by our the Go compiler and by the binary itself. Actually, it's populated by the binary when you run it. But if you wanted to test this run function in isolation, you wouldn't have the os.args because it's kind of an environment variable. So you would have to somewhat extract these dependencies away as well. How do we extract this dependency? Well, we have seen that this is a string slice. So what we could do, we could basically just use dependency injection again, and instead of creating the args here or assigning the args here, what we do, we say, okay, I have the args that just coming directly from the run method now. So now we have the args coming from the outside. We're doing this dependency injection also with the args. Again, we don't need the interface because it's a basic type. So there is not much we have to do here. Whoop. So we just use the spread operator to just pass all the arguments in there, or we could just actually just pass the string slice if it works. I will now check and run it again. We build it, we give it the name, and we specify the file name, and then we do get pop. So now we have we have seen all the dependencies we can think of, because we've seen that we had the args that was coming from we had the args are coded inside our function, and we had the database as well are coded inside our client. We have now more or less removed all the dependencies. Almost all of them. We will see now later why some of them are not removed, like the fumped println. So this is still going to, it's kind of an hard-coded dependency because it's writing to standard output, but we can just ignore that for a moment. It's going to next level, like creating a extremely pure function where it doesn't interact with any external part of the system. It still interacts with the standard output, but there is a way we can abstract this out as well. So we know that it already works now. So the next step, we identified all the various components of that. The next step is trying to write a test for the run function here. So the objective is trying to write a test for this one. Before we couldn't do that because we had, we could attempt to do that, doing a lot of hacks and very hacky code. because we had our database.txt encoded inside our client, our runner. So that would mean that we had to manually check our database file, and it would have been very, very messy. But now we can have our own implementation of that. So we will see now in a moment how this will play out. The first thing that we do, we import the testing package, which is used for testing, and then we always start with test, and then the name of our test case. So the test case, the first test case I want to test an error. I want to test an error is returned. And if you want a refresher on testing in Go, you can go check one of my videos about Go testing. So the first thing that now we do before jumping into the code, we're going to check the main.go. We're going to check how we're going to create the runner, what we need to create the runner, and what we need to run the runner and to return an error. So we need a database, but really what we need is a storage interface. So we can implement our own database that has these two methods, but in reality doesn't write to any file, doesn't do anything. It's like a fake database, and that's what in unit testing we call a mock. It's like a puppet. It's like a fake object that we use to pass around our tests and to make sure that it's behaving like the interface is expecting in this case, but it's not the actual implementation. It's just a fake object that we use to manipulate the behavior of our program. The first test case that we can write is if the arguments, the length of the arguments is less than 3, so that's easy to test. Then what we could do, the second test case, I guess we could pass in a get, and we could simulate, we could make sure that the database.get returns an error. So this is 2 test cases. And then what we can do, we can also test, this is something that is going to come later on, and we can also test that this value is being print out. So the first thing we're going to do, we're going to test that the arguments is the length of the arguments string slice is less than 3. It's trivial to do. So main tests, as we said, we have to initialize our runner, new runner. The new runner takes our interface, which is storage interface, and now we need to implement a storage interface, and we need to create our mock. How do we do that? We can do that by using a struct type and define our own type, mock database, which is a struct. For now it's just empty, because we just need to respect the interface. We don't need to have any specific behavior. Then later on we can adapt this and make sure that it's working as we expect. For now it's just not doing anything. So we're just implementing the interface that we already defined. This is the storage interface again. And this is returning just an empty string and a nil. Mock database, set, string, key value obviously, and an error. And returns nil. So now we have the runner, we have our fake database, and we can pass it in, mock database. Now we have the expected error coming out of the runner.run, and we know that with this empty slice we're gonna have an error. If the error is nil, then there is something wrong. I mean, we should have an error. So what we do here, we just say t.error. We say expected error on empty slice for args got nil. So this is what it does. It creates a runner. It passes a mock database, which is an implementation of our storage interface. It doesn't do anything. It's just a fake object. Again, you have to think about it as a mock object, as a puppet we will pass in just to allows us to work with our client, with our runner here. And then we just call the runner with an empty slice, and we know that with this case it should return an error. So we test that code path. and we see whether that works or not. That passed, so that's nice to see. So if we go again into the main.go, we see that we have passed an empty slice, and that is less than 3, and so we get the error usage. We have implemented a storage interface, which is the mock, again the mock database, that for now is not returning anything. Now we will see later how we can improve that. So we said we want to trigger the database.get. So what we need to do to trigger that is to basically, to trigger the error, is to basically modify our mock object to return an error when we call get, and we will also have to pass the get. We will also have to pass the get string with a key as well, so that our database.get receives the right arguments and then returns an error. So this is our second code path that we want to test. The first code path is the first one here. Then the second one is the get return an error here. We could have done the set as well. We can actually we can do the set first. So it's it just goes it just goes with the actual with the actual flow. We can do the set, and we can do also this length arc is less than 4. So we have a set as a first argument, or second argument, because the first one is the program name, and then we just missed the name of the value that we want to pass in, and that should return an error as well. So we can just duplicate that test case to just quickly see that that's working as we expect it to work. So we just copy paste all of this, and now we just need to change here. We say this is like key value. This is how it's gonna actually look like. Set, then Bob, but then we forget to pass the actual value of Bob, so this should return an error. And we also need to change the name of the test case. Here we say test runner set missing arg error, which means that is missing the arguments for the set. Test runner args error, go test -b that pass. And now it comes the test where we want to call the actual our puppet. We want to call our mock. So test runner set returns error on set. Okay. Test runner, just call it test runner returns error on set. Okay, here we already have it. So how do we make sure? So let's go down into the main.go, and we said we want to go down. We said we went into the line 58. We tested this line. That's fine. We tested line 63 as well. That's fine. Now we want to test line 66. How do we trigger an error in this case? Well, we know that the database is a mock in our case, so it's respecting the interface. It's just a mock, so it's a puppet, and we can make it return whatever we want to. How do we do that? We go back into our test, and the mock database is going to be structured in this way. You can structure the mock database in this way. You can say set error contains what you want to return as a set error, and then you have get error contains what you want to return as a get error, and get string is what you want it to return as a get string. So now we just need to replace all the values here. Get so here you have m.get string, m.get error. So in our mock database, in our puppet, we basically just improved our puppet to behave in a way that we want. So whenever we are going to pass our database a specific get error or get string, this is going to be returned by the runner into the runner by our mock database. And the same goes for the set error here. So m.set error is going to be returning the error that we specify. By default, we leave it everything we leave it empty. So by default, it's going to be empty string and nil error. But for our case, we know that we passed all the values that we needed to pass. We passed set, Bob, and then we passed the value. And now we say that the set should return an error, errors.new, we say something went wrong. Okay, you can even do something like that. You can even do that. It's you know, you could even do set error, errors new, set error, just for simplicity. And now what you can do, set error, you can check that the error that you're receiving from the runner, first of all, is not nil, and if it's not nil, and I think the first thing you need to do is if it's nil, you return. I think we need to split it up because otherwise there's too many cases. First of all, we get the error from the run. If the error is nil, we say that we was expecting the error. We know that the error is not nil now, so we can get the value from it. If the error is not equal to set error, then we also say, I was expecting the error to be a set error. I expected error to be set error got something else. Set error error. We can leave it set error, actually set. And here we can set error and then error to be set error to be. So this is what it does. It basically creates a set error. It tells our Puppet database that each time someone calls set on you, you have to return set error as a result. So we know that now the runner is gonna go through that path where it attempts to set some values. The result should not be an error, so if the error is nil, we error it. And we also know that the result should also be the set error that we passed in here. And if we go down the main.go, we'll see how this will play out. We know that the arguments is not less than 3 because it contains the binary name, it contains set, Bob, and 10. Then we're going to set. We also have 4 arguments this time, so this will not go through. And then arrives the times that the runner calls the database. In our case, it's going to be our Puppet, our mock database. It calls set with Bob and 10, and the result will be an error, and the error will be returned to the runner. In this case, to the test case. And just as something that you will have to be aware of, the runner in our case is the subject under test, so we are testing the runner. And it is also, from a dependency injection point of view, at this time, this is also the client, and the mock database is the dependency. If we were instead to test another components, if we were to test the database itself, the behavior of our file database, then the file database will be the subject under test, and the file.txt, the file string, the file path will be the dependency. So this shifts, the various roles shift based on what type of, what is your subject under test, what is your subject that you're analyzing. So in this case, we are working exclusively with the runner. Obviously, this is something that always do mistakes with this one. You will need to import the errors, and then we will also need to properly call the error function, which converts the error into a string. .45. Set error and error. So we have v error f. So everything now is passing. So what things are missing now from our test? So we have tested almost half of our function. We need to test just the get one and the error usage here. So we can try to test the default one, which is pretty straightforward. The error usage one, what it does, how do we trigger that? Well, it needs to have at least 3 arguments, but what it returns, but it will not be anything like set or get. So we can just pass any string really to trigger this use case. So we can do the objective here is to basically say that the testing is going to be for the test runner usage error, test runner usage error, and then we still pass the mock database, but this time we need to pass at least 3 arguments. We pass key value store, the key value, and then we pass the get, the help, and then I think we can also pass to trigger the default case. We will also have to, because this one will be the first case. If we just pass 2 arguments, it will error at the first case, at the first if. But if we want it to go into the switch case, then it needs to have at least 2 arguments. Then you can do something like help and 1, 2, 3 or something like this, and this will just trigger that case there as well. So now we just missed to test the database.get. So we just missed 2 test cases: the database.get and the return nil here. So this can be triggered in 2 ways. It can be triggered either with a successful set or with a successful get. When you write unit tests, you always need to think of unit testing as going through each different code path that you have and trying to assert each different code path. So in our case, we are trying to go through each different code path. We have been into this code path, so even if this is true, then we assert this code path. If this is false, this is another code path, so it goes into the switch. This is a code path as well here, another one here, another one here, another one here, and then you have 2 other code paths which leads to the same result, which is return nil. So, and this happens if the database of set doesn't return any error, and the database of get doesn't return any error. The database for get.get, we can go through that as well, just to refresh you on the how you trigger an error with the mock object. So we can use the same boilerplate as the set one. Test runner returns error on get this time, and here we can say get error, and then we can rename this get error, and then we know that the mock database should return an error, get error, and get string is going to be 10 as a result. Okay, so we say I want to get Bob, get value of Bob, get value of Bob, and this should do the work. We just need to update this get error, and should do the same here as well, get error. So this should then now yield the same result, so it should pass as well. We have now tested basically all the paths. The only thing that we miss is the return nil here. We can do that as well easily. Also, another thing to bear in mind is that we have not tested the value that is returning from the get database.get. We'll see now in a moment how we can test that as well. Main test, so it's just one use case to miss, a couple of them actually. One is to test the value of the get, which we cannot test yet, and another one, which the one is we're gonna do now, is to test returns nil error, which means that for example, we don't return any error, and we return the string, and the error is nil. So here is, if the error is not nil, then we say yeah, we would expect this to be nil. It's better to be nil on get on mockdb get returning string or something on those lines. Just saying that our database is returning a string and is returning a nil, and we shouldn't expect any error, as you see. So the last we have done is basically we are going into the get case, we are getting some value, the error is nil, is nil, so this doesn't get triggered. We would also print the value and we would exit, and we would test the return nil here as well. And as you can see here, it is also, you know, printing out to the tests, so it's also kind of showing the thing to standard output. You can see now how we can isolate that. The standard output is in itself a dependency, the fampt.println is a dependency in itself. And if we want to bring this even further, a way that we can do that is by passing the standard output into the runner here, so that then we can record what data is being written there. Remember that the standard output is an IO writer, so we can abstract it up, and again we use an interface. So the client, the runner, uses the dependency, which is the standard output. So the output, we call output. We can call it std out for now, standard output, then we can put interface. And fmt println is equivalent to something like this, is equivalent to fmt fmt fprintf you can do, and then you print the string and the new line, and then you pass the b. That's equivalent to what we've been doing. Or you could do output of write, because fprintf calls write in the background, so you can always use what's working under the hood. But write wants the byte slice, so you would have to use the byte slice here. And the byte slice, the byte slice is you can convert the string to a byte slice in this way. This is a bit ugly. So I'm with you that this is a bit ugly. But there is a nice thing about the standard output is that it implements also a write string, so you can write a byte slice like this with write, or you can write a byte string, and you can do that by doing write string. And then what happens is that you would just have v plus, and you go ahead on this way. I don't know. I still prefer just write, because later on we are going to use, the interface. We are going to use something that implements a IO writer to get the value. But it's up to you. You can use whatever you want. You can use fmt, fprintf. It's up to you. So now we're passing the output. It's a dependency. Again, it's a dependency. We are injecting a dependency. This time we're injecting it into the run. I guess we could also inject this into the new runner. It doesn't really, I think it doesn't really change that much, but yeah, that's up to you really. So now we have the std.out standard output injected into the dependency, the dependency injected into the client, into the runner. And we know the standard output implements is an IO writer, so implements the write method. And this is the next step. So the first step, identify the dependency, abstract the dependency, and then identify an interface that the dependency is implementing. So we already have the IO writer, which is using the write method. And now the testing becomes slightly easier for us, because what we are going to do is basically we can use bytes buffer, which is a very handy way for us to the bytes buffer is bytes buffer. It's like an in-memory data structure that it grows dynamically, and where you can write and read data from. It's like an in-memory file kind of thing, where you can write, you can write data and you can read data from. So it's something that's very very useful. It also has the right string, so we could even use the right string there as well. So in the right string has an interface called IO string writer, which is right string. And if you check, and this is also coming from the standard output is a file. So os.stdout is a file, and if you check godoc os.file.writeString, it also has a write string. So now you see that a lot of things that you have all these interfaces and everything works very seamlessly together. That's the thing. That's the awesome thing about code. Everything is very orthogonal. You can compose stuff together and everything works magically. So now what we're gonna do, we said we are going to use a string writer here. We can avoid to convert to string writer, and here we can avoid to convert to byte slice instead. Write string. Okay, so now we also abstracted away the output. We just go back into the tests. And as we said, we are going to use a bytes buffer. So I think it's bytes buffer. I think this should work. So now we just need to replace this bytes buffer. And obviously we need to do it for each call here. Bytes buffer on set, then on get, and in error. Okay. Buffer. And the same applies here. I think this one is the last one, and then we're going to import the bytes package. Let's see if it works. I mean, it is some the main defined IO. I need to add the IO package, which we use for the interface string writer. Can use by faster literal, does not string writer. Okay, bytes.buffer. We need to pass a pointer instead of a simple type. So this is bytes.buffer. And bytes buffer. Okay, let's see if that works now. Okay, everything passed. Now we need to test the that the output we are getting is what we expect it to be, and we could do it in the same test case that asserts the nil, but I'm just going to create a new one because it's kind of a different test case. So test runner, and here what is going to be test runner expected output. So now the buffer, we kind of have to take it here because we need to use it later to see the value. Bytes buffer, and we pass it here, buffer, and yeah, we can also check the error nil. And we can also check that buff.string is not different than than 10. That's what we were expecting to return. And in this case, the error f expected to be 10 got something else, buff string. I guess we can remove the test case of before, because it's the same test case, just have one more condition here. Okay, that's interesting. Buffer to be 10 got 10. There is something to do with the formatting, probably. It's because it's asking for a new line as well. So when you write to the buffer, if you remember, when you write to the buffer, you also write a new line there. So we also need to add a new line to the buffer, to the comparison here, which is not the same as get string result, because again, if you go back into the main, you will see that we are returning the 10 plus the new line, so we'll have to compare that to the new line as well. And everything passes successfully. So we just went through the dependency injection. So we have modified our file to be using dependency injection. We had defined an interface. We identified the various parts of our program that reference to what the dependency injection taxonomy tells us the parts are. And then we have extracted the dependency away. We've extracted the storage. And we have written a unit test for the runner package, for the runner function specifically, for the runner struct specifically, that allows us to test the package without having any particular external dependency. We could also have, I think in one of the other episodes we can go through testing the file database, but I think this is something you can try do yourself. If you have any questions, just drop them down below or in the Slack channel, and this is going to be very similar. If you look at the file in the new database, you already have some sort of dependencies that we are extracting. The only dependencies that are not extracting here is new dependencies, the file, which this can also be extracted away. And so this is, I think, is a good exercise for you if you want to go through the dependency injection on this one. So you can then write a test that tests the database, and where the database is the service and is the client, and the service is the file as a dependency, as an outside dependency. So this is also another test case you can go through. But yeah, that's what we went through today. It's basically just going through an example of dependency injection, how dependency injection can improve your code, and specifically how then you can use dependency injection to write better tests with Go. I hope you like the tutorial, and see you in the next one. Thanks.